Hello and welcome everyone, and thanks for joining us in a new episode of Let's Talk About Data Show. My name is Ibrahim Amar. I'm a database specialist solutions architect here at AWS, and I'm based out of London. As usual, we always discuss data related topics in our show, whether it's related to the databases, database migrations, data streaming, analytics, and all related topics. In today's episode, we will continue what we have started last week when we started discussing the Oracle Database at AWS, the offering that we have to host Oracle workloads in AWS. And for that, I'm also glad to be joined today again with my colleague Joe, who was with us last week. Joe, for those for our viewers who were not there last week, would you like to give a brief overview about your background, please?
Yeah, sure. Thanks, Ibrahim. Hi, everyone. Thanks for joining us. Welcome back. My name is Jobin Joseph. I go by Joe, a senior database specialist at AWS, primarily focusing on Oracle database related services. And today, I'm so excited to be here to discuss with the Oracle Database at AWS offering the joint partnership with OCI, the second session of the two-part series. I'm based out of Toronto, Canada.
Thanks, Joe. And we have Prasad as well, who's helping us with the chat. So please feel free to send your messages, your comments, your questions, and Prasad will be able to answer them. And okay, Joe, last time when we started this discussion about the Oracle databases at AWS, we covered several topics. We gave a brief overview about the service itself or the offering, to be more precise. And we mentioned how it's a marketplace offering to host the Oracle workloads on Exadata machines running inside AWS data centers. We discussed briefly about the architecture of the Oracle database at AWS, the different use cases, why we are offering this for our customers. And also we started by giving our viewers a demo about how they can provision the Exadata infrastructure and create a VM cluster. And on top of that, how to create the database, which I believe we are going to start with this time, right? But
That's
before
correct.
that, just a quickly let me see if we have viewers. We have our regular viewer, Edith. Hi everyone, Eri, and also we have our producer Jeff, who is helping us with the show. Thanks, Jeff. So, Joe, back again to summarizing the architecture and starting from there to go with the demo or the part of that where we stopped last time after we created the VM clusters.
Sounds good. So just to set the context for anyone who joined us just today, skipping the first part of the session, like Ibrahim mentioned, Oracle Database at AWS is an offering from AWS jointly partnered with OCI to make Exadata cloud service and autonomous database on dedicated infrastructure available for our customers to make it so easy to migrate Exadata and real application cluster dependent workload to AWS. The primary use case is that, but we also have other benefits because the Exadata infrastructure or the hardware is deployed inside AWS data centers. You can expect low latency connectivity from your applications to the database running on Oracle Database at AWS. And this comes as a marketplace offer for you. It's not a native AWS service, but we have built in a way that you get it like a native experience. Service integrations and other integrations are giving you that kind of a native AWS service experience. You also get benefit of unifying your data across AWS and Oracle, and other benefit includes simplified experience of end-to-end life cycle, starting from provisioning the infrastructure operations as well as the purchasing is made easy through marketplace. Um, just to make sure that everyone understand the demo part of it, I want to start with sharing the architecture diagram we briefly covered in the first session. But I'll start from that so that we can follow the demo instructions or demo part of it very nicely. So
Oh,
let me.
let me just quickly, we have other viewers who are joining us on chat right now. So we have Crazy DB5, a regular viewer joining from Mumbai. Hi, Crazy DB5, schizophrenic, web developer. Hello, hello. And Kishore joining from New Jersey. Hey, Kishore. And okay, perfect. So, and we have GridDB5 saying that, Joe, I love reading your blogs. Perfect. So you have fans here.
Thanks for
Okay, let
thanks for
me
that.
let me share your screen. Okay.
All right. Okay. So this is the same architecture slide we saw last time. So to explain the architecture, I'm taking the example of a region where the service offering is currently available in GA. Let's take US East 1, where AWS has a region which we call US East 1, and OCA also has a region which is known as US Ashburn 1. And inside the AWS region, in a specific availability zone, inside AWS data center, we have the OCI child side, which is hosting the Exadata infrastructure or the hardware. So think of OCI child side as an extension to the OCI parent region inside AWS data center, and there is all backbone connectivity between the OCI child side inside AWS data center to the OCI parent region for all the control plane operations and automation, backup, and things like that. And on top of the Exadata infrastructure, you can create VM clusters either for creating Exadata databases or autonomous databases. And these databases will be hosted on the VM clusters. And on the networking piece, we are introducing a new network construct called ODB network. ODB network will host all Exadata client network and client network and backup network resources. All the communications to the database will be made through ODB network. ODB network maps to an OCA VCN on the OCA control plane. So when you create ODB network, it will create an OCA VCN automatically with the same CIDR range that you pass as input for the backup subnet and client subnet. And ODB network is the mechanism to establish connectivity to your database from your AWS ecosystem. For example, if you have an application running in your VPC, that VPC can be connected to ODB network by peering that VPC to ODB network through the new mechanism called ODB peering, very similar to VPC peering. And once the peering is established, there will be connectivity. For example, the EC2 instance hosting your application can establish database connectivity through ODB network to the database tier. So that's a kind of architecture overview to start with before we switch to the demo.
Perfect.
Okay, let's go back to the console. All right. Okay, so this is the landing page for Oracle Database at AWS offering. If you go there, you will see the dashboard enable once you accept the marketplace offer. We went through that process and explained the concept last time. When you accept the marketplace offer, you are basically reviewing the private offer given by Oracle against your account, see the terms and conditions. If you're satisfied, you accept that offer, and it completes, then it enables the dashboard. And during that process, you also link your AWS account with a specific OCI tenancy. So just to emphasize this point, Oracle Database at AWS is still OCI database services. There are two services offered, ADB and XRDB. And that's why it's important to complete the linking process of connecting an AWS account with OCI tenancy. That's how all the resources that you create are correctly placed in the control plane on the OCI side, because these are OCI based services. And I have completed that process as well. So I have my OCI tenancy, and we will take a browse on the OCI OCI control plane resources. What we saw last time was we looked at various resources that can be created from the AWS side. So you have the ODB network, Exadata infrastructure, the VM cluster, both Exadata VM cluster and autonomous VM cluster, and then the peering part of it, right? How to establish connectivity from your VPC to the ODB network. ODB network, we saw the creation process. I
Yeah.
don't want to take a lot of time. So basically, you're just passing the CIDR range for your client subnet and backup subnet. You're also choosing the availability zone. So ODB network is an IAC specific resource. So you need to choose which availability zone you're creating the ODB network. Ideally, should be the same availability zone as your Exadata infrastructure. So once you create a ODB network, you will deploy your Exadata infrastructure. Again, pretty straightforward. You choose the availability zone and choose your desired configuration. You want X11 or X9. We recommend going with X11, the latest model. Choose your number of DB servers and storage servers, and that's pretty much it. So these two resources were created last time. Now we going to create the VM cluster, which is on top of the Exadata infrastructure, and we will use the ODB network for placing the network resources of the VM cluster. Now, again, we briefly went through this last time, but we will just quickly see the options once again to make sure that we see what are the parameters required to create the VM cluster. So you put a name to it, put the grid infrastructure name, time zone of your desired configuration, either you want to go with license included or bring your own licensing model. Choose infrastructure, which you created earlier to place your VM cluster. Go with the latest version of grid infrastructure and Exadata image, if that's what your preference is. You're also given the choice of going with an older version of grid infrastructure. If you like to kind of reproduce your exact on-prem environment, you choose the number of DB servers and storage server to be part of your VM cluster. Now, VM cluster, if you can think of it, this maps to your rack cluster configuration. So if you like to have a 2-node rack cluster, 3-node rack cluster, this is where you configure that. Now, but remember, one configuration is influencing that decision is number of DB servers on your infrastructure. So in my case here, I'm shown only 2 DB servers for my VM cluster. That means I can only choose maximum a 2-node rack cluster configuration. That's because my infrastructure, underlying infrastructure, has only 2 DB servers. So if you like to have more DB servers part of your rack configuration, you need to have similar number of or higher number of DB servers on your underlying Exadata infrastructure as well. And this is where you can configure the resources for your VM cluster, how many eCPUs or OCPUs you need per VM, and the memory configuration, the local storage where all the software installations go, and the Exadata storage for hosting your database, the ASM disk group, that's can be configured here as well. And you see the 240 terabyte as the limit of the maximum storage because I have 3 storage servers in my Exadata infrastructure. Each of the storage servers comes with 80 terabyte of usable storage for an X11M configuration. That's why you see these numbers are shown as the maximum threshold for the configuration. And 760 ECPs are again driven by the number of DB servers.
And
And
for
you
the storage, Joe, the level of the mirroring level of the data or the protection level, because you mentioned the usable storage is 80 terabytes. This is
Yes,
not the raw storage.
that is correct. So 80 terabyte per Exadata storage server for X11M is the usable amount of data. It's not the raw data, raw storage capacity. So considering the high redundancy configuration of ASM, that's the default and mandatory configuration of
Mm,
ASM in Exadata Cloud Service. So 80 terabyte is what you actually get to host your data. So yeah,
perfect.
yeah.
Okay, perfect. So we are talking about 3 copies of the data or the mirroring here at the ASM level.
That is correct. Primary copy with two mirrored copies. That is right.
Perfect. Uh, before we continue, we have a question. Actually, 2 questions. Kishore is asking, is there any guidance on how does customer decide the required configurations being shown here?
Yes, so it is important to choose the right configurations to run your workload. And if you're migrating from an Exadata on premises, it would be a good starting point to look at what your current configurations are. For example, if you're running multiple databases consolidated in, for example, a quarter rack kind of configuration, that could be a starting point. But you always look at the resource utilization, because the difference between running Exadata on-prem versus Exadata in any cloud offering like Oracle Database at AWS is that easy scalability. So you may have provision your resources to cater for your organic growth for next 6 months or 1 year, where in an Oracle Database at AWS, you really don't have to over provision resources. So you can look at what exactly you need for your current workload requirement and start from that. And at any point in time, very easily, you can add more number of DB servers and more number of storage servers as your demand goes up. For example, we started with 2 and 3 DB to storage server configurations. And tomorrow I need to add more storage capacity. I can independently add a storage server. And like that, I can add up to 32 DB servers and 64 storage servers in my configuration. So if you go back to my Exadata infrastructure, I can modify that configuration to scale the resources. So you have that options available, and you can also do it from OTA console.
Perfect. And also another question from CrazyDB5. Can the new VM clusters be added or removed going forward after creating them?
Yes, you can change the configuration of existing VM clusters once created. Absolutely fine. You can create more VM clusters on the Exadata infrastructure. The limit is that 8 VM cluster. 8 is the total number of VM clusters that you can create, and this is combined both Exadata VM clusters and autonomous VM clusters.
And within the VM cluster itself, can we add or remove database servers?
So I'm trying to understand the question. So within the VM cluster, can I remove VMs from the VM cluster? Because DB server is the configuration of the infrastructure.
Exactly.
VMs are the part of the VM cluster.
Yeah, if exactly, can similar to as CrazyDB5 saying, similar to rack add node or delete node.
Yes, you can scale up and down the VM cluster. So scaling up is similar to you're adding more node to your rack cluster, and scaling down is like you're removing a node, right? So Oracle Database at AWS, you can even run a VM cluster with single node. Like this configuration, if I go with, it will have only one rack node part of my rack cluster.
Perfect. Thanks.
But obviously, for production workload, we need to have at least 2 DB servers to benefit from the real application cluster features. One node is down, your workload is still able to access your database. All right, so I'll go with some minimum configurations. You can also configure your storage to support local backup, and you can also configure to support sparse disk group for thin clones of your database. So these are features supported in Exadata Cloud Service, and they're available in Oracle Database at AWS as well. And according to this configuration, your ASM disk groups ratio changes. How much of it going to data? How much of it going to record? How much is going allocated to sparse? That ratio is based on your choice here on this console. So what it cannot change at a later point is this part of the configuration. What are the different type of data you plan to storage on the disk group? Are you going to store it local backup? Are you going to configure ASM disk group for sparse? You cannot change this configuration, but this resource configuration, how much of memory, CPU, and local storage, these configurations can be changed later. And this is where you choose to decide which ODB network you're deploying your VM cluster. So remember, when you create ODB network, you mentioned a lot of parameters like what is my CIDR range for client subnet, backup subnet, etc. And it is going to derive all these values from there. Exadata configuration and rack cluster configuration requires a lot of IP addresses, as you know, nothing different from your on-prem world. You need host IPs, node VIPs, private IPs, and scan name, 3 scan IPs, scan listener, all those network requirements are derived from ODB network. You can put a prefix for your rack cluster nodes. If you have a preference, you can do that. You can change the scan listener port. You can also put an SSH key pair where you will be using the key pair to connect to the Exadata VM cluster using SSH once it is provisioned. So I'll go with some random value so that I can go to the next screen, and you can configure to enable some events and trace collection for diagnostic purpose, optionally add the tag, and then submit the VM cluster creation. Now, VM cluster creation is the most time-consuming resource in the whole provisioning process because it builds heavy components like grid infrastructure, ASM, real application cluster, database home. And that's why this will take a couple of hours, probably 4 to 5 hours for a 2-node rack cluster. And it can increase based on number of nodes in the rack cluster. If you have 8-node cluster, it can be longer. Autonomous VM cluster creation is pretty straightforward, very similar to VM cluster, standard Exadata VM cluster. The only difference here, if I can go to that screen, is that here you don't mention any SSH keys. So the storage configuration, those details remain same, but you don't have an SSH configuration. And that's because autonomous VM cluster, you are not connecting to the underlying Exadata VMs, right? So you don't have access to Exadata VMs of autonomous database VM cluster. You only have access to the database layer, that to the PDB level. That's why you don't pass the SSH key as a parameter while building the autonomous VM cluster. But otherwise, the configuration is very similar to the Exadata VM cluster. Now, so you have built your ODB network, Exadata infrastructure, the VM cluster for autonomous database and Exadata database. The final step you have to do on the AWS side of configuration is building the connectivity. So how can your application running on a VPC can connect to the ODB network? So that is implemented through the ODB peering construct. So you can create an ODB peering connection and choose which ODB network your Exadata VM cluster is deployed into that you want to connect from your VPC, and choose your VPC. So this is the VPC ID where your applications may be running that needs to connect to the database for database connectivity. So you choose that VPC and create ODB peering connection. Request will be submitted to make that connectivity established from your VPC to the ODB network. So once the peering is established, the EC2 instances, for example, can connect to the Exadata VM just like they are communicating between two EC2 instances.
Okay, Joe, there's a question before we move on. So Kishore is asking, what's the equivalent of autonomous database in AWS, and what are the use cases that would drive toward OCI autonomous database?
So autonomous database from the managed experience, you can compare with RDS. So RDS Oracle provides a managed experience similar to autonomous database. All provisioning, management, backup, failover, those kind of activities are automated for you. But I would say autonomous database is little more than that. Autonomous database comes with machine learning integrated features that automates many administrative tasks as well. For example, it's like you create the database, pump in your data, and start using your application. You don't really need to worry about kind of creating indexes or tuning your queries. It is all done automatically for you using machine learning integration. So that's kind of an enhanced feature of autonomous database that is not available part of RDS Oracle. And also autonomous database built on top of Exadata infrastructure, while RDS is more on EC2. So what exactly the use case for autonomous database, that really depends on your requirement. For example, if you're looking for the features that are only available in autonomous database, the ones I highlighted about, and also looking for example, database versions such as Oracle Database 23 AI that is currently not available in RDS Oracle, for example. And if you're running your database applications on AWS and looking for Oracle Database 23 AI capabilities on the Oracle Database tier, then autonomous database, part of Oracle Database at AWS, could be a database platform that you could consider hosting your database.
Perfect. Okay, so now we have we provisioned the Exadata infrastructure. We created the VM cluster that has the VM machines and the ASM or the grid infrastructure home, and we also paired the ODB network with the VPC or the application VPC. So what should be the next step?
Correct. So the next step should be creating the database, right? So we created the VM cluster, completed the connectivity part of it. Next is creating the database. Now, creating the database is, you have two options. So we will try to show both options. Either you can connect to the Exadata VM cluster using SSH keys that we already kind of shared as an input while creating the VM cluster. So you should have the pair key of that and then use that to connect to the Exadata VM cluster. And once you're in the Exadata VM cluster, you have access to all the OCI cloud automation tools, including Deba CLI, for example. And using the Deba CLI, you can create the databases using CLIs. So that's one option. But sometimes customers prefer to have kind of a console experience. And this is where we need to switch to OCI tenancy for completing the database creation part. So which OCI tenancy? Again, if you remember the marketplace offer acceptance discussion, during that process, we are linking an AWS account to an OCI tenancy, and that's OCI tenancy where all the control plane resources will be hosted. So we'll be using that tenancy to create the database resource. So let me go there. So this is the OCI tenancy I have already logged in. And how do you get into Oracle Database at AWS related resources? So you choose Oracle Database here. You can choose either Exadata database on dedicated infrastructure or autonomous database on dedicated infrastructure, depending on which type of database you're going to create. So let's go to Oracle Database, Exadata database on dedicated infrastructure. Here you can see all the VM clusters that you created from your Oracle Database at AWS side of console, right? So you created number of VM clusters here. All those VM clusters you can see here as well, because these are the kind of a control plane resource holder for all the resources running in Oracle Database at AWS. Now, you can
also, Joe, from the AWS console as well, there are direct links that will take you to those VM clusters, right?
Very good point. Yeah. So let's take an example of one VM cluster that is already created. And if you go into the properties of that, you can see there is an OCI resource tab. And if you click on this one, it will directly take you to the OCI resource in the OCI console, mapping to this AWS resource. That's another way of getting into, that's the easiest way of getting into your specific configuration or resources that you are currently working on. I was just showing from, if you arrive in OCI console, how to navigate to resources in ODB at AWS. Right. So this is the VM cluster. And if you go to the database tab, I have a few databases already running. In our mind, we'll create a new one. You can put a name to your database. This is the display name, and this is the database unique name. So I'll put some dummy values here. Choose 19C 23AI. If you chose your grid infrastructure version as 19C, then you won't be able to create a 23 AI database. So that's kind of a compatibility metrics you need to keep in mind when choosing what grid infrastructure version you want to go for. Probably 23 AI will be a wiser decision. So 19C 23 AI database, I will choose that. Here you can choose to create an existing home or create a new database home for your database. If this is the first database you're creating in this VM cluster, definitely you have to create a new database home. In my case, I have an existing 23A database. That's why it's giving the option to you go with an existing one. You can put a name to your pluggable database, the first pluggable database that will be created on your database, and your admin credentials as well. There is nothing much on this configuration. So, and You can either use the same password for TD wallet or put a different password. So that's one configuration you can choose. And database backup, that's an interesting discussion. So the database backup configuration. So like I said earlier, Oracle Database at AWS comes with kind of a managed experience. So many of the tasks are automated for you. One of the important one is managing the backup. It comes with automated backup, and you have multiple options to choose the backup destination. For example, you have Amazon S3 as the default choice, meaning the backups taken for your database will be stored in an Amazon S3 bucket. And the other options for Exadata are Autonomous Recovery Service, which is with the ZDLR appliance deployed in OCI parent region. And the third option is OCI object storage. So these are the backup destinations supported today for Oracle Database at AWS. For Exadata, for ADB, we will see ADB creation screen. Autonomous recovery service is currently not supported, but Amazon S3, which is a default, plus OCI object storage are available as the backup destinations. And you can choose your backup retention period and also your preferred backup window. These are RMAN based backup. So good to choose a maintenance window or backup window that probably a lean period for your business, so that RMAN backup, when you transfer full backup once a week, it will not impact your critical business activities. You can also put some additional configuration details like Oracle set, database character set, and national character set, encryption configurations, whether you want to go with Oracle managed keys or customer managed keys. The default is Oracle managed keys with the wallet stored in Exadata VMs in ACFS file system. So I'll keep that configuration, and then you can submit the creation request. So that's the creation of an XDB. Now we can also.
There's a question also from Kisho's asking, is there a reason one chooses 19 when you have the latest version? I believe all depends on the compatibility with the application that you have. If your application is compatible with the 23 AI, then this is something that you might want to go for.
Correct.
Yeah, any other use cases? Because even when who's working on premise, yes, we used to have like a current version that we are using for our databases, but the effort related to the upgrade, sometimes you compare this to the benefits that you will be getting from the new features and whether you are using them or not, and then you can decide. This is, as I mentioned, in addition to the compatibility, of course.
Correct. I totally agree with you. I think the only reason I can think of 19C going with 19C database is because application support and compatibility reasons. But otherwise, considering that both 19C and 23AI are long-term supported versions from Oracle, I would normally consider 23AI as the first choice if there is no concerns with application compatibility issues. Now, that's another interesting discussion. So if you have any preference to go with 23 AI, or you are interested in any features that are only available in 23 AI, for example, vector store, vector search capabilities, those kind of features, then 23 AI probably is the only option, because 19C don't have those features. So it's all driven by your specific workload requirements and application compatibility metrics.
Perfect, thank you. And that's the same thing what Chris DB5 is saying. Yeah, it's 19C, same as 23I is a long.
Correct. I believe 19C support, a premier support itself is going all the way to close to 2030. Joe, sorry, Brian, do you remember the exact year?
No, 30,
okay.
31, 32, something like
Correct.
that. So still have enough time. And we have a comment from Schizophrenic with Developer. Is this show sponsored by Oracle today? No, it's not. Still an AWS offering that we want to cover because, as we mentioned last time, there are some use cases. We have been working with our customers for years now, and there are actual use cases where our customers showed the interest in a solution like this, and that's why we are offering this solution. And in our show, and you will see later on, we will show how this offering or how this Oracle database at AWS is integrated with the AWS other AWS services as well, so that to give you the full experience.
All right. Okay. So we saw how to create an Exadata database. Now let's look at the options to create autonomous VM, autonomous database also. So we have few autonomous VM clusters already available. Similar to the case of Exadata VM cluster, if you go into the OCA resource tab, you will find the link that will take you directly to this resource in the OCA console. If I click on that, I'm on the OCA tenancy, the same OCA tenancy. And something I want to show you here is the autonomous database VM cluster specific configuration. So here is the VM cluster page. So all the details you can see here, the scan port, maintenance window, all the details that you passed as parameters that when you create the autonomous VM cluster from the AWS console. So autonomous VM cluster, on top of that, you can create an ACD, autonomous container database. So that's a requirement before you can create actual autonomous database. The actual autonomous database is a PDB, pluggable database on top of the container database. So you need to create a container database first. So you can click on autonomous database, container database. Okay. So I reached capacity on this. So what I'll do is that I'll just show one of my existing ACD. So basically, you create autonomous container database. You mentioned the backup configurations, whether you want to enable data guard, which autonomous VM cluster you're creating this one, which infrastructure the autonomous VM cluster is part of. It's pretty straightforward process. You can also mention the resource configurations, how much of eCPUs are provisioned and reserved for this autonomous container database, and also the encryption and backup details. And once the autonomous database is created, you can go and create your autonomous database on top of that. So you created a container database. Now you're creating your actual autonomous database, which is a PDB on the container database. So you put the name, the display name, and the database name. Okay, let me spend a minute to explain that. When you link your AWS account with OCA tenancy, one thing it does is it creates a compartment called multi-cloud link compartment, and your resources will be placed under this. So if you have multiple compartments, the multi-cloud link compartment helps you organize your Oracle database at AWS specific resources. In many cases, customers may choose to link their AWS account with an OCA tenancy that is an existing one, and they already have resources on that. This may be an existing OCA customer, and they may have many resources running under that tenancy. So by having a dedicated compartment, helps customers organize the resources under different compartment for whatever resources that are created by Oracle Database at AWS. And the reason you see there are two different sub-compartments under the multi-link compartment is because we are sharing some resources between two AWS account, and that's using AWS Resource Access Manager. I'm going to show some kind of architecture diagrams and slides to explain that. Okay, so once you choose your database name and the compartment, you can choose where your database is going to be autonomous data warehouse or autonomous transaction processing. Now, these are the two type of autonomous databases supported by Oracle Database at AWS. While in OCA, you may find other choices also. For example, there is autonomous JSON database and globally distributed database. those options are not available for autonomous database creation, part of Oracle Database at AWS offering. Now, choosing this one really depends on your workload type. So if you're primarily data warehouse workload, you go with data warehouse. Otherwise, if it is more general purpose use case or transaction processing, you choose ATP or transaction processing. And this is where you will choose a container database on top of which this autonomous database will be created. And these are the options to control your resource allocation, initial number of eCPUs. You can also enable elastic pool on this one. This is an advanced concept of consolidating multiple autonomous databases in ADP to reduce the cost and licensing. So you can use that configuration for optimizing the licensing cost. That's one configuration. You can also enable auto scaling for your resources. What that means is that based on the requirement and resource utilization, autonomous database will automatically scale the resources up to 3 times of initially allocated eCPU. For example, if you start with the ECP configuration of 2, auto scaling can automatically go up to 6. Okay, you can put the credential for the admin user, and under advanced configurations, you may find encryption keys details. This is derived from the container database manage configuration. That's where showing an option to change it. You can change the character set though, the primary database character set and the national character set. You can configure database in memory if it is at enable on the ACD level, and then you can submit the database creation for your pluggable database. Now, once your pluggable database is created, I have one already existing here, and then you can connect to it. For example, if you go to the database connection, it has all the connection parameters already displayed here. How do you connect with different pre-configured service names? For example, ATP comes with pre-configured service name for transaction processing, medium, urgent. These are pre-configured services based on the various workload requirements. It automatically comes with fixed amount of, for example, maximum number of concurrent sessions, parallelism enable. So you can look at the configuration supported by each of the services and choose one of the services for using for your application configuration. You can also...
Is that managed by the resource manager at the database level?
Yes, that is internally managed by resource manager, but you don't have control. These are pre-configured one. I am assuming that you may be having option to create additional ones, maybe using some API calls, but these are pre-configured ones.
Perfect.
You can, so connections can be either TLS or without TLS. That's where you see some of the connections examples showing TLS as in the name. And if you're using TLS, you need an SSL wallet. So you can download the wallet to have SSL certificate that can be used in the client for connectivity.
Joe, we have 15 minutes left in our show, so I think we already covered the creation of the databases. I believe we can quickly go through the connectivity, how to connect, and then we move to the integration with the other services.
Correct. So let me show you how to connect to the database. We already discussed the connectivity options using the ODP pairing. So that's the mechanism I'm going to use. So I have a VPC that is already paired with the ODP network. We already saw that configurations. In that VPC, I already have an EC2 instance. So if I go to my EC2 instance, I have one. Let me connect to that. I'm fetching my Exadata VM cluster details quickly. So if you go to the, go ahead.
Yeah, so I was going to say, so for the autonomous database, you are connecting directly to the database. You don't have access to the underlying VM machines, so there is no SSH. It's just SQL Plus connectivity or whatever client you are using to connect. But in the Exadata VM clusters, you can do both. You can do the SSH to the VM machines, or you can run using SQL Plus or whatever the client to connect to
Correct.
the database. Okay.
So I'm on the Exadata VM cluster page. Under the virtual machines, I can see my two nodes of the rack cluster and I can get the DNS name. I will spend a minute to explain the DNS because that's important.
Mm-hmm.
Um, so we have the DNS listener automatically configured on the ODB network as part of the automation. When you create the ODB network, it's already up and running. The DNS listener is provisioned. So if you have your applications running in the VPC, how can it resolve the DNS names for example, scan or Exadata VMs? What you can do is that if you're using your Route 53 as your DNS resolver, you can configure an outbound resolver endpoint and outbound resolver rules to point or to delegate all the name resolution for Exadata domain to the DNS listener running in ODB network. So the ODB network, if you go into the ODB network configuration, it will show you the DNS listener IP. So you can configure the resolution using outbound resolver endpoint pointing to this DNS listener IP. So I got my Exadata VM details. So I fetch the details and I already have my SSH key saved in my EC2 host. So I have my SSH key here and I use my SSH key to connect to my Exadata VM. And that takes you to the Exadata VM. You can see it connects as OPC user. And once you're in OPC user, you can probably switch to root, install any commands you want, any installation you want to make, any customization you want to make. If you want to connect to the database, you can switch to the Oracle user. You can look at what are the different databases running on there and set the environment variable for that, and then connect to the database. Once you are in the Exadata VM, pretty similar to how you deal with these things in the on-prem world. There's no much difference. Only thing is that Oracle configures all these configurations automatically for you, so you don't have to set up the environment manually.
Perfect. So this area you're going to connect to the cluster or the VM cluster ExaDB on ExaDB, and from the autonomous database, you showed us how the connection strings that you can use in order to connect to the database, and still you need to do the peering between the cluster and the or the ODB network and the VPC of the application, and then you do the DNS resolution part in order to resolve the host name.
Correct.
Okay, perfect. So now we need to know more about the integration between the ODB service or the ODB at AWS offering and the other native AWS services that we have. Because I
Correct.
think this is one of the main benefits that the customers will be benefiting from when they are hosting their Oracle workloads on ODB at AWS.
Yes. So the Oracle database at AWS is a marketplace offering. The way we have integrated that part into AWS console and built all the integration with the rest of AWS services is like a native AWS service. So we have native integration built from Oracle database at AWS with a few other AWS services. I just want to call out the important ones. So it's not a full list. One is that the CloudTrail. So all the API calls that are made for Oracle database at AWS is logged into AWS CloudTrail, and that's important for any auditing and governance. And also there is an integration to AWS CloudWatch. So performance metrics at the VM cluster level, table space level, database level, these are all automatically integrated with AWS CloudWatch, and you can see those on the CloudWatch page. There is also, we talked about connectivity by VPC peering, but connectivity is not limited just using VPC peering, ODB peering. You can also extend the connectivity using transit gateway. So if you have applications running across multiple accounts, multiple region, or if you like to establish your connectivity from other network segments outside AWS, for example, applications still running in AWS, on-prem world, and database is migrated to Oracle Database at AWS, you can establish the connectivity using transit gateway. And transit gateway will be an attachment to the transit VPC, which will be connecting to the ODB network through ODB peering. So many customers use CloudOne, which is kind of a managed transit gateway configurations where customers use CloudOne for global connectivity across their entire AWS footprint across many regions. Now we have support for CloudOne integration with ODB network. So similar to transit gateway, you can also use CloudOne for extending the connectivity from your ODB network outside your transit VPC. CloudOne can be made as attachment to the transit VPC. And we also have VPC Lattice. Many customers use VPC Lattice for securing their connectivity. So we talked about some integrations initially about zero ETL, backups are enabled to S3. So for all these internal AWS service integrations, we use VPC Lattice framework. Now, customers can also leverage the VPC Lattice configuration for a kind of secure connectivity from their Exadata VM to some resources running in the VPC. For example, there is some TCP applications running in the VPC, and Exadata VM has to connect to that. They can establish a secure connectivity using VPC Lattice. So that's an option. Now, backup, we already talked about Amazon S3. Many customers asked us initially when we just didn't have a backup destination in Amazon in AWS side, because otherwise the data has to traverse between AWS and OCI region when the backup destination is, for example, OCI object storage. And many customers have compliance requirement where the data must sit inside AWS. And that's why we supported S3 as the destination for automated backup. So that backup integrations happens automatically for you. You don't have to configure anything specifically from your side. You just need to choose backup destinations Amazon S3 when you configure or create your database. And you saw that option when we saw the demo of creating a database. We also have zero ETL integration with Amazon Redshift, which we briefly talked about in the previous session. So without having to do any manual ETL pipeline build, with few clicks on the AWS Oracle Database at AWS console, you will be able to build a data pipeline, which automatically replicates your transactional data, both from your XRDBs and autonomous databases to Amazon Redshift cluster. Be it a provision cluster or Redshift serverless, it will automatically propagate the data without you have to do manually any data replication mechanism. And once the data is in Redshift, it's available for other capabilities. For example, you can use Redshift ML, and all those options are available. So these are the main integrations which are currently available in Amazon Oracle Database at AWS with other AWS native services.
Perfect. Before going further with those integrations, just we have a comment from Tom is asking no caption available. I'm not sure if our producer Jeff can answer something like that regarding the captions. And also we have a question, but before going to that question about the migration, yes, we mentioned that the S3 integration for the backup, but it's not only limited to backup, because we were discussing that before, is that using packages like the DBMS Cloud that's being offered as part of the Oracle database, you can access files directly that are being stored in the S3 bucket. So you can leverage this functionality or this feature so that you can access those files directly, maybe through an external table, for example. So the files will be stored there in an S3 bucket, and then you can query those files directly from within the database. And also other integration that we were talking about just before the show is the integration with Bedrock, for example. If you want to use the Bedrock for the AI its AI capabilities for embedding your data, something like that, generating vectors, embedding vectors. So you still can do this on ODB at AWS and access all those services. So uh, we have a question about the migration from non-ODB to ODB at AWS, and what are the tools that are available for that?
Yeah. So migration is a very interesting topic, and in terms of what tools and features are available for migrating your existing database, probably running in on-prem environment to Oracle Database at AWS, you have a wide choice of tools, both physical migration strategies and logical migration strategies, or a combination of tools that will give you kind of a zero downtime migration strategy. So in terms of physical migration tools, they are supported for migrating your database to Exadata database on dedicated infrastructure. And you can use, for example, RMAN backup restore, full incremental restore, setting up a data guard. These are the common mechanisms that customers use. And on top of the physical migration strategies, you can also use logical migration tools, for example, Golden Gate or Oracle or AWS DMS, export data pump. All these tools are available to migrate to ExaDB. Now, Oracle also has an orchestration tool called ZDM, Zero Downtime Migration Tool, which under the hood uses some of the tools we just explained, like data guard and things like that. But it automates and orchestrates end-to-end migration process, makes it so easy for customers. So we have seen OCI team mainly recommends CDM as the primary migration tool for migrating databases to XRDB and ADB. Now, one thing I want to call out here is that autonomous database, because it is a kind of fully managed service with no access to the underlying physical virtual machine or Exadata VM clusters running that database, you cannot use a physical migration strategy to migrate to autonomous database. For example, you want to migrate from your Exadata on-prem to autonomous database, you cannot use Arma backup and restore, or setting up a data guard configuration, because that is a physical migration strategy and you don't have access to do that. But you can very well leverage the logical migration tools like Golden Gate or for export data pump, and then set up CDC using Golden Gate. Or if you like CDM to orchestrate that for you, that is also taken care by CDM, so that you can achieve a zero downtime migration tool to migrate databases to autonomous database in part of ODB at AWS.
But thank you so much, Joe, for those two informative sessions about the offering the Oracle database at AWS. And thanks everyone who have joined us today in this session. And as you know, this session is being broadcasted to both Twitch and YouTube. You can go back and review the first session and also the recording of the session as well if you want to. And again, thanks a lot, Joe, and thanks for our viewers. And we'll be waiting for you next week, same time. So we will be discussing next time. We'll be talking about the zero tail integration as well, but this time for the RDS Oracle. So it's an exciting feature, and we'll see in more details how you can set it up and how you can leverage the different functionalities of the Redshift. Thanks, Joe. Thank you so much. Hope to see you again in our upcoming shows. Thank you.
Thanks, everyone.